Hello class, welcome to lesson 2, additive and subtractive color. Before we get started, let's go over why learning the theories verbally is demanded further than the art classroom. Learning to incorporate the elements and principles in artwork is skillful, but it is not enough. The State Common Core requires you to possess procedural and verbal skill to pass to the next level. Declarative skills are important, and you are being taught declarative skill information. Mostly, once the class is over, the elements and principles are retained by being able to remember how to use them, but not take a test in them that requires declarative information and verbal expressing. Let us begin then. The additive primary colors are red, green, and blue. Additive color is the color you see displayed on your computer or other electronic display device. Combining balanced amounts of red, green, and blue lights produces pure white. In the RGB system, the red, green, and blue dots on the computer represent brightness values along a scale where, for instance, 0 is dark and 255 is bright. By listing the red, green, and blue three values for the phosphors, you can specify an exact amount in hex value code. When combined, additive colors get lighter. As each component of light is added in, the combination becomes a new color. With the three additive primaries, you can mix any color of light with different combinations of the additive primaries. When you mix all three together in balanced amounts, you get white. You can specify an exact color by listing the combinations of the red, green, and blue phosphors, as you can see by the color checker chart on the screen. A value comes from the natural colors of the Color Rendering Index based on natural daylight by the International Commission of Illumination. It is a 6-place RGB hex value. Phosphors are luminescent substances that, when excited by radiation as electrons, emit light. Phosphors are used in computer monitors. Note the terms for your journal. Pixel is short for picture element. A pixel is a single point in a graphic image. Graphics monitors display pictures by dividing the display screen into thousands or millions of pixels arranged in rows and columns. The pixels are so close together that they appear connected. The number of bits used to represent each pixel determines how many colors or shades of gray can be displayed. For example, in 8-bit color mode, the color monitor uses 8 bits for each pixel, making it possible to display 2 to the 8th power, 256 different colors or shades of gray. On color monitors, each pixel is actually composed of 3 dots, a red, a blue, and a green one. The quality of a display system largely depends on its resolution, how many pixels it can display, and how many bits are used to represent each pixel. Ideally, the 3 dots should all converge at the same point, but all monitors have some convergence error that can make color pixels appear fuzzy. VGA systems display 640 by 480, 300,000 pixels. In contrast, SVGA systems display 800 by 600 or 480,000 pixels. True color systems use 24 bits per pixel, allowing them to display more than 16 million different colors. The RGB model only produces a certain gamut of colors. This is why some colors cannot be accurately displayed by a computer. The number of colors visible on a monitor is decreased by the proficiency of the computer's video hardware, which can display from just black and white to up to 16.7 million colors. The subtractive primary colors are cyan, magenta, and yellow. Subtractive colors get darker when mixed. Each of the mixed paints or inks absorbs different components of the light. When the right combination of paints is mixed together, all of the components of light are absorbed. The result is a near black. Printer's colors, or the cyan, magenta, yellow, black subtractive primaries, make any color. Mixed together in equal amounts, CMY is a near black. This is where CMYK comes from. CMYK is used by printers, and K stands for the key printing plate. CMYK is a generally accepted color model term. If you will notice on the screen, CMY is a triad. It is sometimes referred to as the triad, but naturally there are more triads on the color wheel. On the screen's next to last frame, you see examples of triadic artwork. Additive and subtractive color, red, green, blue, RGB, and cyan, magenta, yellow, black, CMYK, are also your computer's color modes. Designers display for the web in RGB and print in CMYK. Remember, RGB is web display color and CMYK is printing color. Designers are able to select the correct color mode in which to create and process a design. Designers must be careful because RGB color printed is not CMYK printed. Also, if a customer is set on a color, the designer must check with the printer. Designers cannot simply deliver a project and say the printer printed it that way. He or she would not be paid. The CMYK color model is often referred to as four-color process due to the fact that it utilizes 4 different colored inks to create an array of different hues. The name CMYK comes from the 4 colors applied during the printing process: cyan, magenta, yellow, key, or black. The reason that black is referred to as key is because it is the color used in the key plate, which supplies the contrast and detail for the final image. In CMYK, the key color is always black. With other printing methods, such as two-tone printing, the key tone could be another color. Of Newton's 7 main colors, each color is monochromatic, meaning each color is composed of a single wavelength that cannot further be divided into other colors. Newton's main colors were red, orange, yellow, green, blue, indigo, and violet. The learning value of mixing paint with only 2 colors is almost any color can be produced with the colors of the spectrum to get all tints and shades of the hue. The theory of simultaneous contrast by Michel Chevreul explains colors effectively used when creating a composition. Review this video until you learn these concepts. Copy them for your journal. Thank you. See you in lesson 3.